Okay. Okay. In introduction, okay, just now I said that for initial value problem, okay, we have two method, Taylor method order n and Runge-Kutta method order 2 and order 4. Okay, but I will skip order 2, okay, because okay, I confident that if we discuss Runge-Kutta method order 4, automatically you will understand how to solve using Runge-Kutta method order 2. Okay, just this is similar to Taylor method, Taylor method, because Taylor method order 1, Taylor method order 2, Taylor method order 3. If we discuss Taylor method order 3, it will be include Taylor method order 1 and okay, order 2. So same goes to Runge-Kutta method order 4. Okay, if we discuss Runge-Kutta method order 4, if you see the formula for Runge-Kutta method order 2, we will automatically, okay, you will know how to solve by using Runge-Kutta method order 2. So different to different Taylor method, Taylor series method, Runge-Kutta have their own its own formula, okay, where okay, the formula okay, will be given. So yi plus 1, so next value for okay, we still solve the same situation or same problem. Okay, we have x0 x0 and y0, so x1, okay, y1 until xn, okay, yn. So to approximate value for y1, so we need to have okay value for x0 and okay y0. So to approximate using Runge-Kutta method order 4, so we have this formula, so yi plus 1, so next value for y equal to yi plus 1 over 6, k1 2 plus 2, k2 plus 2, k3 plus k4. Okay, we have k1, k2, k3 and k4. Okay, where? Okay, what is k1, k2, k3 and k4? So here, this is the definition of the equation for k1, k2, k3 and k4. Okay, where k1 equal to h, okay, where h is interval, yes, h for interval, we choose to solve okay, this problem. So h fxy. So what is fxy? Fxy is ky prime. So same as initial value problem Taylor method. So we have y prime equal to fxy. So now okay, we using same fxy. So y prime equal to fxy. So this is fxy we use in Runge-Kutta to substitute a value of xi and yi here. To h is interval, and then we substitute value of x. For example, if we want to solve y1, so we need to use x0 and y0 inside this fxy. So and then we calculate k1. So from k1, okay, we can calculate k2, okay, because k2 need k1. K2 equal to hf x plus h over 2 and y plus k1 over k over 2. So okay, in order to calculate k2, okay, we need to calculate k1 first. So just okay, find the value for x and y to substitute into f here. So we have x plus h over 2 and y plus k1 over 2. Okay, you need to calculate this value and then substitute into f. And same for k3 equal to h f x plus h over 2. Okay, same as above. Okay, but for y plus k2 over 2. So for k3, okay, we need to have a value for k2. And k4 equal to h fx plus h y plus k3. So to calculate k4, we need to have k3. So that is the formula for Runge-Kutta method order 4. So you need to calculate y is k1, k2, k3 and k4, and then after we calculate k1, k2, k3 and k4, we just substitute into the main formula for Runge-Kutta method order 4, and then we calculate this one, and we obtain the next value for y. So example, okay, we try to solve same problem in Taylor method. Okay, y prime equal to 1 plus y over x with h equal to 0.25. The interval is 0.25 and the range of x is from 1 to 2. So with initial value y1 equal to 2. Okay, so for Runge-Kutta method, Runge-Kutta order 4, we need to calculate k for every k for for every I to calculate y1, we need to calculate k1 to k4. So k1 for y, okay, this one is for I equal to 0. So I equal to 0 is to find y, okay, y1. So to find y1, I equal to 0. Okay, we need to use x0 and y0. So for k1 equal to h f x0 y0. So 0.25 is interval, h equal to 0.25, f1 2 because x0 equal to 1 and x0, okay, x0 equal to 1 and y0 equal to 2. And okay, we substitute into the function 0.25, okay, 1 plus y over x, so 2 over 1 equal to 0.75. So this is the value for k1. Value for k1. Okay, next. Okay, k2 h f x0 plus h over 2. So x0 plus h over 2 is okay, x0 plus h over 2 equal to x0 is 1 plus h 0.25 over 2. So 1.15, 1.125 here. And y0 plus k1 over 2. So y0 plus k1 over 2 is 2 plus k1 is 0.75 over 2. So y0 plus k1 over 2 is 2.375 here. And then, okay, substitute this value into function f. So 0.25, 1 plus 2.375 over 1.125, okay, using calculator. So we have the value for k2. K2 equal to 0.7778. Now make sure to do this calculation carefully, because if you make mistake, k1 automatically you will make mistake for k2 and so on. So please calculate carefully. So k3 equal to hf x plus h over 2 y plus k2 over k over 2. So same type of calculation. So x equal to 1 plus 0.25 over 2, so 1.1.25. Y0 is 2 plus k2 0.777x over 2. So we have 2.388. Substitute into f prime into fxy or y prime. So we have k3 equal to 0.78009. And last we can calculate value for k4. K4 equal to h fx plus h y0 plus k3. So please be careful also the formula for each k. Don't make mistake. So k use the original f x y, k2 and k3 use h over 2, k1 over 2, h over 2, k2 over 2. And for k4 we use fx plus h. There is no over 2 in this h, and y0 plus k3. So there is no over k over 2. So we have 0.25 f 1.25 2.7 x0 k09 to substitute into fxy or y prime, and then by using calculator, we have value for k4 at 0.8062. And after we calculate all value for k, k1, k2, k3 and k4, So we can substitute into the main formula. Main formula of sorry. Okay, we substitute value for K1, K2, K3 and K4 into the main formula. So we have a value for KY1. So Y1, solve this using calculator 2.7789. So we have a approximation, and when x equal to 1.25, y equal to 2.7789. The next value for y2. Okay, so this calculation is when I equal to 1. Okay, we want to solve what is value for ky2. So again, we need to calculate k1, k2, k3 and k4 for I equal to 1. Okay, do same type of calculation. Substitute the right value. Make sure not make any mistake in this calculation. And and then after we calculate k1, k2, k3 and k4, calculate and substitute into the Runge-Kutta main formula. So we have y2 equal to when x y2 equal to 3.6082. Okay, when x equal to 1.5, y2 equal to 3.60x2. So do the same thing to y3 and y4, and as usual we try to compare the result with we compare the result with exact solution, and we found that RK4 up to 4 decimal places give 0.000 error. So up to 4 decimal places, we can say that there is no error. No error. We still have error. Okay, but for up to 4 decimal places, okay, in this problem, okay, we not the RK4 not giving any error. Actually, RK4 is widely used uh, in research. In research, especially for mathematician, mathematician, if we want to solve initial value problem or first order differential equation, okay, we will use RK4 instead of Taylor method. So RK4 is more popular to use by mathematics researcher. Okay, any question for RK4? You know? Okay, no. All good. Okay. Okay. Thank you. All good. Okay. Okay. I said just now. If you can understand to how to calculate to solve the problem using RK4, okay, it will be automatic. You can solve using RK2. So let's see. Okay. What is RK? Okay. RK2. Okay, this is the formula for RK2. RK2 we have two method, Hune method and midpoint. Okay, midpoint method. Okay, where this is the formula for Runge-Kutta method order 2. So yi plus 1, okay, same. We have for every method, okay, for RK order 2 we have Hune and midpoint. So Hune method is yi plus 1 equal to yi plus 1 over 2 k1 plus 1 over 2 k2, where k1 equal to this khfxy and k2 equal to hfx plus h and y plus k1. And the formula will be given. So you need to calculate k1, and then you calculate k2, and then substitute k1 and k2 inside this formula, and we have the next value for y using using this formula. Okay, that's Hune method. And for midpoint method, we have yi plus 1 equal to yi plus k2. Yi plus k2 only, okay, but k1 is hfxy, and k2 is hfx plus h over 2 and y plus k1 over 2. Okay, this is the partial calculation for rk4. Rk4, okay, we have k1, k2, k3, and k4, and then we substitute k1, k2, k3, and k4 into the uh, formula, Runge-Kutta formula. So for midpoint method, okay, this is the formula. So I think you know how to calculate k1 and k2, and then substitute into the main formula. So we obtain the next value for y. And it's good if you try to solve this example, okay, that I already share in our WhatsApp group. Okay, try to solve this problem. Okay, maybe you can try to solve also. So there is more example. Okay, solve this. Yeah, I suggest to try to directly solve using Runge-Kutta method order 4, okay, because okay, if you observe uh, a past year problem, uh, the RK2 RK order 2 will never be being asked, only RK4, each semester only RK4, okay, will be asked. And okay, RK4 also give a good approximation, good solution. Okay, there is okay, I think also no question.